This is example 2-13, a swimmer valve, where we have this little ball that's connected to an arm, and the level of the water is controlled by this little ball. Right, as the water goes up, it's going to push harder on B, and maybe that opens a valve. And once it goes down, there's no more force on B, so maybe that closes the valve. Right, so that's how this will work. We're given that it has a mass of 150 grams, and then we have all this. We are asked to find what the different forces are, the support reactions are within A and B. So to do that, of course, we have to draw ourselves a free body diagram. Be our arm here and there. We know we'll have some support reactions where B is. That's just going to be a normal force. Then we're going to have a vertical component here and a horizontal component, AV and AH. We're given the mass, so we know that we're going to have a weight. And of course, half of the ball is submerged in water, so that means there's a buoyant force acting upward. FB. We already also know that this distance right here, the length of the arm, is 450 millimeters, so 0.45 meters. And we also know that the height of this arm here is 100 millimeters, so 0.1 meters. All right, so of course, A, V, A, H, and B is what we're going to try to get, and W and FB are things that we can figure out independently. So let's start with a weight. No, the weight is just M times G. That is 150 grams times 9.81 meter per second squared, or 150 times 10 to the minus 3 kilograms times 9.81 meters per second squared, and that is 1.4715 newtons. So that would be our weight. Then we can also calculate the buoyant force. Right, we know that the buoyant force is just the weight of the liquid that's being displaced. Now in our case, the weight that's being displaced is being displaced by this little ball here, but the ball is only half in the water, so we'll take half of the volume of the sphere. So let's have a look there. So we can say our FB would be 1/2 the volume of the sphere times gamma water. All right, so that's 1/2 times 4/3 pi times r cubed. That's the volume. Then times gamma. So those cancel out here. So we have 2/3 pi r cubed times gamma. That is 2/3 times 75. Oops, forgot a pi in there. 75 millimeters cubed times 9,810 Newton per meter cubed. Can convert that to meters. 2 pi over 3. 75 times 10 to the minus 3 meters cubed, 9,810 Newton per meter cubed. And that comes out to be 8.66785 Newton. All right, so now we have the two forces, which means we're left with three unknowns, A, V, A, H, and B, and of course we have three equations. So I'll say we'll start with B. We can do a moment around point A, and then B is going to be the only unknown. So let's say sum of moments around A is equal to 0, and see what we get. Well, we get the weight is going to go in positive. Moment arm of of 0.45 meters, which means that the buoyant force is going to go negative with the same arm, right? Because it's was acting exactly the same in the opposite direction, but parallel. And then we have B. B goes in positive as well, 0.1 moment arm. So plus B times 0.1 meters. That means we can solve for B. B is then, so B was positive, so we have to flip the other side. So it'll be FB times 0.45 meters, minus W times 0.45 meters, and all that divided by 0.1 meters. FB we have up here, so it'd be 8.66785 newtons times 0.45 meters, and the weight was 1.4715 Newton, also times 0.45 meters, and again all of this divided by 0.1 meters, and that gives us then 32.38577 Newton, or if we round it, 32.4 Newton. All right, that's our first support reaction. How about the other ones? So we could do a moment around B, which would give us a H, but we can also do the sum of forces, right? Because they're all good. Let's give ourselves a little XY here. So we can do sum of forces in the X direction, and then sum of forces in the Y direction. So we can say sum of forces in the X direction is equal to 0. What do we get? Back to our free body diagram. In the X direction would be here, so we have minus B and minus AH. Minus B minus AH, that means AH is minus B is minus 32.4 Newton. All right, so it's acting not to the left like we have it here, but to the right. And then for our forces in the Y direction, right, we have W, FB, and AV. So that would be sum of forces in the Y direction is equal to 0. We had negative W plus FB plus AV. That means AV is equal to W minus FB, and that is W was 1.4715 Newton, and FB was 8.66785 Newton. That means AV is minus 7.19635 Newton. If we round it, we get 7.20 Newton. So it also is pointing in the other direction that we have it, right? So we're saying it's pointing upward. It really should be pointing downward. All right, with that, we have our 3 support reactions, and we're done with this problem.